Imagine a giant, impossible blade dropping from space to cleanly slice the Earth perfectly in half. In science fiction, the two halves might drift apart like a chopped apple, but the cold, hard reality of planetary physics dictates a very different, far more violent story. If that cut happened with zero immediate physical separation, the two halves wouldn't float away. Deep inside the Earth, the core and mantle are under immense lithostatic pressure, the crushing weight of the thousands of kilometers of rock above them. Under that kind of stress, rock behaves more like a highly plastic fluid than a solid. The extreme pressure would force the two halves to instantly fuse and re-weld themselves together. Look at this boundary between the deep ocean and a developed coastline. On the surface, this instantaneous re-welding would cause localized geological devastation. The physical cleavage plane would sever human infrastructure in a fraction of a second, tearing through transcontinental oil pipelines and snapping international subsea telecommunication cables. Then comes the thermal shock. As billions of gallons of ocean water seep into this newly formed lithospheric fissure, the water makes direct contact with the superheated rocks of the upper mantle. This creates rapid thermal flash boiling, triggering catastrophic steam explosions and massive volcanic venting all along the seam. Because the interior layers are highly pressurized, this deep physical crack acts exactly like a burst tire. The sudden release of trapped internal pressure would force the molten sections of the Earth to erupt outward, creating massive tectonic rifts and pushing continents apart as millions of simultaneous eruptions vent trapped gases and silicate rock. Even a perfectly smooth cut with no immediate separation turns a stable, layered planet into a localized tectonic apocalypse simply due to the release of pent-up internal pressure. So what if you actually wanted to pull the two halves apart? To physically separate a planet-sized mass, you have to overcome its gravitational binding energy. This is the ultimate mathematical barrier, the absolute minimum energy required to completely disassemble a planet and push its mass to infinity. This diagram shows the Earth modeled with its dense iron-nickel core and outer layers. Because our planet is highly differentiated with varying densities, calculating the exact energy to split it into two coherent, infinitely separated halves yields an astronomical number, roughly 9 times 10 to the 31st joules. For perspective, our total annual energy consumption is roughly 11 orders of magnitude smaller. It would take billions of years of humanity's current power production to generate enough energy to make a permanent split. But let's assume we somehow cross that impossible energy threshold and manage to pull the planet apart. We would not be left with two stable, flat-faced half-Earths drifting through space. Overcoming the gravitational binding energy to pull the halves apart is simply the trigger mechanism. What follows is a violent physical reaction dictated entirely by the laws of thermodynamics. In planetary physics, any body exceeding a few hundred kilometers in radius is forced into a spherical shape by its own gravity, a state known as hydrostatic equilibrium. Because of this rule, a perfectly severed planetary hemisphere is a highly unstable, physically impossible state. The raw mechanical forces inside a hemisphere of this size are staggering. The gravitational overburden pressure at the center of the half-Earth reaches hundreds of gigapascals. This completely overwhelms the structural shear strength of the silicate rocks and iron-nickel alloys trying to hold the flat shape together. In this deformation model, the physical response is immediate. The flat central face violently bulges outward, while the sharp outer edges collapse inward. On a planetary timescale, this collapse resembles a viscous fluid rapidly flowing and reshaping to minimize its surface area. Under the overwhelming force of its own gravity, solid rock behaves exactly like a liquid. This rapid physical transition from a severed hemisphere into a sphere releases a massive amount of stored gravitational potential energy. For both halves combined, the collapse generates over 7 times 10 to the 30th joules. All that kinetic movement creates extreme internal friction. Viscous dissipation and shock heating convert the violent reshaping into raw thermal energy. This instantly spikes the average temperature of the rock by over 1200 Kelvin, with even higher concentrations of heat along the shearing boundary layers.
This gravitational collapse alone provides roughly 75% of the total thermal energy required to globally liquefy the entire mass. The result of our cleanly split world is a pair of perfectly spherical, glowing protoplanets, their entire crusts and mantles melted down into deep, roiling magma oceans. Gravity doesn't gently reshape a broken planet. The raw friction of that reshaping completely sterilizes it, replacing a habitable world with twin molten hellscapes. This image of the Pluto-Charon system demonstrates what happens next. Assuming the two Earth halves separate at a speed below their mutual escape velocity, they don't drift off into deep space. Instead, they enter a gravitationally bound binary orbit, circling a shared, empty center of mass. At close range, extreme mutual tidal forces pull on the newly formed liquid spheres, stretching them into elongated teardrop shapes. Viscous friction inside their molten interiors rapidly drains their rotational energy, tidally locking them so they always face each other. A single day on these new worlds would equal the orbital period of the system, likely lasting about a month. But this new binary system creates a massive problem for the Moon. The Earth's perfectly symmetric gravitational grip instantly vanishes, replaced by a chaotic multipole expansion, a highly irregular gravitational field that heavily disrupts local space. As this orbital map shows, the Sun now dominates the gravitational tug-of-war. The Moon faces one of three immediate lethal fates. It gets gravitationally stripped into an independent solar orbit, pulled into a direct collision with one of the Earth halves, or spirals inward until tidal forces tear it apart. If the Moon crosses that inner boundary, the Roche limit, it is shredded into a spectacular ring of orbital debris. Over time, thousands of massive, shattered lunar fragments would rain down relentlessly onto the newly formed molten Earth halves. The friction from this continuous atmospheric bombardment creates a heat wave intense enough to vaporize any crust attempting to cool. Splitting a massive planet completely breaks its local orbital architecture. It turns a stabilizing ancient satellite into catastrophic cosmic shrapnel. While slicing a planet in half with a giant blade is pure science fiction, the physics of this scenario actually mirror the verified history of our early solar system. Look at this heavily cratered surface. The Moon is the literal surviving evidence of a planet melting impact. Under the giant impact hypothesis, a Mars-sized planet named Theia struck the young Earth roughly 4.5 billion years ago. That collision liquefied our young world, destroyed the primitive atmosphere, and formed the Moon from the ejected debris. This image of Mercury tells a similar story. Early in its formation, a catastrophic collision stripped away a massive fraction of its outer silicate mantle, blasting the debris into space and leaving behind only a dense, iron-dominant core. When planet-sized bodies collide or are torn apart, they don't leave behind jagged, floating fragments. The immense energy released by gravitational collapse and kinetic impact invariably melts the rock, forcing the surviving mass into molten consolidation. If the Earth were split in half today, it wouldn't be permanently destroyed. It would simply reset its evolutionary clock. The laws of gravity and thermodynamics dictate that no matter how absolute the destruction, perfect spheres will always be relentlessly rebuilt from the chaos.